Alright, so for the airplane problem, we are given a altitude of 10 miles when the plane is 15 miles from the antenna with a changing rate of 375 miles per hour. Right here we have our changing rate of 375 miles per hour, which we're going to label dc over dt since that is the c side of the triangle. And the way we did it was by plugging in Pythagorean theorem, a squared plus b squared equals c squared, taking the derivative of this, which b gets left out since it is a constant, and then you plug in the speed that you found, since we found speed first in our method, and after you plug it in a calculator, you get 11.180 miles. Now, another method, which is easier and doesn't involve finding the speed first, you can do a squared plus b squared equals c squared, plug in the 10 squared and the 15 squared that were given for the altitude and the distance from the satellite, set it all equal to a, take the square root, and you get 11.180 miles. Now, to find the speed of the plane, you do a squared plus b squared equals c squared, since we're still on our right triangle here. You plug in the 10 squared first before you take any derivatives or anything, since it is it's a constant value that we're given beforehand, and that does not change. Since the distance does change, we can't just plug that in right here. Now we set a equal to the square root of c squared minus 100, since in the end we're going to have to find the speed of the plane, which is going to be dA over dt, which is the derivative of that. So derivative of a over derivative of at is just going to be the 2c over 2 times the square root of c squared minus 100 times dc over dt. And after plugging it into your calculator, you multiply this value by dc over dt, which is given to us as the rate of change of the speed, 375 miles per hour. And your final speed is 503 miles per hour.